Assalamu alaikum, dear students. I hope you are fit and fine, doing well at your places during these COVID lockdown. And I have already told you, you should take care and you should strictly follow the SOPs of this COVID guidelines. This time I want to deliver a lecture. It is on differential equations, introduction and origin. Actually this is on this will be lecture number 1. Lecture 1. I want to dedicate this lecture for 5-year integrated course, especially in our J&K state. We have JKIMS, JK Institute of Mathematical Sciences, where I am delivering my lectures. It is for them and all undergraduate classes who are doing BSc Mathematics. Some have this course in semester 2nd, some have semester 3rd. Whatever it is, this is the syllabus there. But before defining, you basically start the differential equations with the definition, order, then solution, so on and so forth. I want to share with you the origin, how these differential equations originated, and later on I will also tell you what is the application of where we apply these differential equations in applied field branch of mathematics. That is not our job. Applied branch of mathematics is separately different, but still I will throw a light on that, where we can use these differential equations. But at this time my lecture will go on this origin, how these differential equations originated, what was the purpose, what we get from these differential equation, why we use it. Now this lecture will for all these undergraduate classes will serve for these syllabuses, which is the part of your this syllabus. It will cover that, and I also suggest the 12th class students, the first 4 or 5 lectures, they can also get a very good benefit from this if they watch this video. 12th class students, they do have a differential equations there, but after 4 and 5 lectures we have to go some higher. We have to deal with the higher concept of differential equations, but this is the basic. In basic we will first give you some origin of differential equation, then we will go on definition, then order, then solution and methods of solution, how we solve the differential equations, so on and so forth. And after that we have to go higher, this exact differential equations, second order differential equations, so on. So let me introduce how I introduce without giving definition. I am not giving definition yet. I want to just give it its origin, how this originated. That I will, for this I will consider an equation. Consider an equation. I will write x square plus y square is equal to r square. This is equation. Do you know which equation it represents? It is a circle with center at origin, radius r. You know it. It is a circle. It is equation of circle with center origin, a radius r. You know it. Now for giving different values to r, if I give r is equal to 1, 2, so on, you will get x square plus y square is equal to 1. You will get x square plus y square is equal to 4. You will get x square plus y square is equal to 9, and so on. And this will be called, now this set of equations is the members. These will be members of family. Members of family given by first. When we give different values to r, we get these members, x square plus y square 1, x square plus, and actually if you look, what does this represent here? You see, what is this actually? This represents a family of concentric circles like this. Family of concentric circles. Center you have origin. Now this equation x square plus y square is equal to r square represents this family of circle, concentric circles. The set of equations given by second is the members. These are the members of family of concentric circles, which are each is centered at origin. Do you know? This is what you know previously. I am not giving something new. You give different values to r, you get this family of circles. This is x square plus y square 1, this will be x square plus y square 2, this will be x square. If you write this is your x square plus y square 1, this is your x square plus y square is equal to 4, and so on. Represent the family of circles. Now our aim is we want to find out an equation which is satisfied by each member given by second. The equation which is satisfied by this, each member of the family given by this, and should be free from r. Why it should be free from r? Because in each member of the family r is now different. Here r is different, radius is different. So how do we find out that equation which is satisfied by each member of the family given by this? This is the member, these are the members of the family given by this. We want to develop an equation. I will not name a differential equation, I will name an equation. We want to find out that equation which is satisfied by each member of this family, satisfied by this also satisfies that equation, this also, and that should not involve r. Why it should not involve r? Because r is different for each member of the family. Okay, yes, this is my objective now. Now we want to find out an equation. I want to find out which is satisfied by each member of family of circles. Second, I name it second. This family I name it second. Each member of the family of circle, which should be the required equation which I need should be what? Should be free from r as as R is different for different member of family. Why? Because if you consider this circle, here R is different, it is 1 square, here it is 2 square, here it is 3 square. So I want to have an equation. That equation should be such, this should satisfy that, this equation should satisfy that, this equation should satisfy that for different values of R. It's a very interesting thing. So how we proceed is, I am not giving you the definition of differential equation, I am just giving you what actually differential equation represents. You can say this time we are also giving the physical representation of a differential equation, the geometrical representation of it. This is a geometrical representation of a differential equation. What is geometrically? I am not yet giving you the definition. Definition you will start with each and every book. You start the definition like of this differential equation. What is a ordinary differential equation? Then partial differential, then order, so on and so forth. You will get it from each and every book. They start from that. But I have started here from the origin where it originated. Okay. You see how I proceed. I will take the main equation from which I have generated these members. I have generated these members from this equation. Now take the equation x square plus y square is equal to r square. This was my equation. I differentiate this. Differentiate with respect to x. With respect to x, you mean y is your dependent, x is independent. Okay, it is 2x plus 2y dy by dx is equal to 0. This gives x plus y dy by dx is 0. Now what is this? This is an equation which does not involve r, and this will be the equation which is satisfied by this. This is satisfied, this circle satisfies this circle satisfies this circle satisfies this circle satisfies this, each and every satisfies this. How? You will come to know later on. I will tell you, if I try to solve this, the method which will come after 1 or 2 lectures, if I want to solve this, its solution will be x square plus y square is equal to some constant. What was your equation? X square plus y square is equal to r square. R square is also constant. You can denote r square by c. Do you know? Okay, x square plus y square is equal to this. So what does this represent? This equation, is the equation which is satisfied by each member of the family given by first. Some of you may ask me how I satisfy myself that each member will satisfy this family. Okay, I will go this way. I will ask you, you take any member arbitrarily. Let you take x square. Take x square plus y square is equal to 4. It is also a member of this. Will it satisfy this? Yes. If I find here, it is 2x plus 2y dy by dx is 0. It is x plus y dy by dx is 0. So when I solve this, it satisfies this. Or if I simply use the value of y here, it satisfies this. Okay. Now this is the equation which is satisfied by each member of the family given by x square plus y square is equal to r square. I will now give this name. This is the differential equation. This will be what? Differential equation. Why differential equation? Because it contains derivative. It contains, because of the existence of derivative, we give it a name as differential equation. Otherwise, what is a differential equation? Differential equation is an equation which represents the family of some curves. It represents the family of some curve, members of the family of some, which is satisfied by the members of the family of some curves given by any curve of the equation. So this is the origin of that. I will give you one more example. Suppose I have okay, let me consider y is equal to mx. What is this? It is a straight line. Almost it passes through the origin. If I give different values to m, you give different values to m. When you give m0, when you give m0, you will get y0. So this is your y0. This is your y0. This will be equation passing by this, different equations. Otherwise, this in this way also. So it represents different equations. It is a family of this, you called members of family. These are the members of family given by first. Different equations passing through the origin for different values of m. Even you can give m negative. In that way, it will go this way, negative side. Now, my aim is to find out that equation which is satisfied by each member of this. By each member, it will be satisfied by this line, that will be satisfied by this line, that will be satisfied by this line. Find the equation which is satisfied by each member of the family, and that should not involve m, because each member of this family has m different for different, m is different for a different member of the family. It should not involve m. That means, in other words, I have to find out an equation, eliminate m there. When n gets eliminated and you get an equation, that will be the equation which is satisfied by each member, will be called a differential equation given by this. You see, what I do, I differentiate this. It is dy by dx is simply m, x is 1. Using this m in first, you get y is equal to x times m is dy by dx. So what is this equation? Of course you will say it is a differential equation, but actually if it is different, it represents something. It has some origin, it has some meaning. Every differential equation has some meaning. What is this meaning? It is meaning is that it is satisfied. It is satisfied by each member of a family given by what? Given by some curve. Given by some curve. What is our curve here? It is y equal to mx. Y equal to mx is also a curve. Straight line is also a curve, because you know what is actually straight line. When two curves, straight line is the curve of intersection of curve of intersection of two curves. Line of intersection of two curves, the straight line. Very good. And this is our differential equation. Differential equation given by this. What does this represent? It represents the equation which is satisfied by each member of this family. It gives us different members, infinite number of members. Every member satisfies this, has a place in this in any way. Okay, I will give you one more example. Consider y square equal to 4ax. What is this? You know, it is parabola. What is the focus of this? A 0. So when you give different values to this A, you get different shapes of the parabola. This parabola is like this, you know. Focus. You can get a family like this. You see, this is the family. Family given by y square equal to 4x for different values of A. How we get these parabolas? For different values of A. Now we want to find out, an equation which is satisfied by each member of the family given by first. You have seen that this y square equal to 4ax, it gives the members, every member has this vertex origin. Vertex is here, origin here, you know, parabola. Vertex is origin and focus is changing. A is changing for different value of A, it gives different parabolas, and all form the members of the family or given by this. Now you are interested to develop an equation which is satisfied by every member of the family, and it should not involve A, because A is different for each member of the family given by A, which should be free from A. How we proceed? We differentiate this. Differentiate first with respect to x. This will give you 2y. dy by dx is what? It is only 4a. Derivative of x is 1. Now use this 4a. Use 4a in first. You get y square is equal to, the value of 4a is 2y dy by dx into x. Well, this gives you y square is equal to twice xy, the value of 4a, twice xy into dy by dx, like this. Now this will be the equation. This is the equation which is satisfied by each member. What is the solution of this? Actually, I am talking up in terms of solution. What is the solution of this? Solution of this equation is each member of this family. This also satisfies this, this also satisfies this, this also satisfies this, this also satisfies. It is a very interesting thing. The single equation represents the family of curves. It is the beauty of differential equation. I have not yet defined a differential equation. I am just giving you it is origin, how it originated. Okay, this is the equation which is satisfied by each member. You see how many solutions it has. So we say this equation is what? It is a differential equation. This will be called differential equation. Why differential equation? Because it involves differential coefficients. Sometimes of first order, sometimes of second order, sometimes of nth order. Okay. Okay, let me give you one more example. You have here only one constant. Sometimes we may have two constants. Okay. I consider equation, it is ellipse, equation of ellipse, and you know that it is major axis is 2a, minor axis is 2b, a is greater than b. This is the major axis, this is the minor axis, you know, where a is always greater than b. So its shape is just like oval shape, egg shape. So when for different values of a and b, it will take different shapes. So all will represent the members of the family given by this for different values of a and b. Now my aim is to find out an equation. Is it possible to find out an equation which is satisfied by every member of the family, which is satisfied this when a increases, satisfied this, and all represent the members of the family given by this for different values of a and b. So in that case I have given you this example because it involves two constants, parameters, we may say a and b. We have to eliminate simultaneously a and b. We should not involve a and b. We want to find out, we will find out an equation which is satisfied by each member of the family given by first given differential for different values of a and b. Further, a required equation that I need, required equation should not involve what? A and b. It should be free from a and b. Why? Because a and b is different for different member of the family. So in other words, we will find out, we will differentiate this, we will eliminate a and b. The equation we get is an equation which is satisfied by each member, and it will be called the differential equation given by that. Not yet definition, just how we make something, where what is the utility of the differential equation, beauty. And later on we will give the definition and order extra. You see how I proceed. Let us differentiate here. Y with respect to x. It is 2x by a square. It is 2y by b square, but y is a function of x. That will be dy by dx is equal to 0. Well, it gives you x by a square plus y by b square dy by dx is equal to 0, or you can write x by square. It is x by a square is equal to minus y by b square dy by dx. You may write here minus a square by b square. I will transpose this to this side, minus also. It is y by x dy by dx. This implies y by x into dy by dx is equal to minus a square by b square. Let me check it here. If I cross multiply this, this is bx b square x. Here we have committed a mistake perhaps. This b will go here, I'm sorry. it is minus b square by a square, b square by a square, y by x, dy by dx. Okay, this is b square x. Here also it is b square x, it is a square y. Here it is also a square y minus. It is okay now. This implies y by x into dy by dx is minus b square by a square. Now I have not yet eliminated here a square and b square. So what I do is I differentiate again with respect to x. Let us differentiate this equation again with respect to x. When I differentiate again, I will use here product rule for differentiation. This means derivative of y by x with respect to x, first function, second function as it is, dy by dx, plus y by x as it is, derivative of dy by dx with respect to x, derivative of right side is 0. A and b gets eliminated. A and b gets eliminated. And here I have used the product rule. Derivative of first function second as it is, then plus first function derivative of second. Now what is derivative of this? Just look. U by v form. Denominator square, denominator as it is, derivative of this, dy by dx minus y, derivative of 1 is, x is 1. X square, x, dy by dx minus y, derivative of 1 is this. It is into dy by dx, it is plus y by x, it is d2y by dx square. This gives you second order differential equation. It is a second order. When you have more constants, you will see later on. The number of independent constants that a differential equation involves depends upon its order. If its order is second, it will involve two independent general solution. Two independent constants. If its order is 3, it will involve three independent constants. You have seen here our original equation had two constants. So when we form the equation which is satisfied by each member of the family given by x square by a square plus y square b is equal to 1, that has come automatically of second order because of two constants. Yes, this is your you can write in this way also. It is 1 by x dy by dx square whole square minus y by x square dy by dx plus y by x into d2y by dx square. In other words, you will now say this is the equation which is satisfied, whose solution is each member of the ellipse that I have shown you, each member of that equation. It will be called a differential equation. This is a some differential equation because it involves differential coefficients. Okay, this is a little bit I have given you the origin of differential equation. Actually, what a differential equation represents, what for it stands. So in the meantime, I want to clear a query. A student has doing engineering. He asked me about trajectories. Here the question answer to that question which student posed on my WhatsApp. He was telling me when we find out this trajectories and orthogonal trajectories. It is not the part of syllabus of the students this BSc second year for whom I have dedicated this video. It is not the part of that. It is for engineering, because the answer to the query comes here. You see, we will go to the definition of this. What is the definition of this trajectory or orthogonal trajectory? It is a curve which touches each member of the family of curves according to given law is called trajectory. Now, what is orthogonal? A curve which touches or intersects each, I will use the intersects word, each member of the family of एक गिवन कर्व होता है, फैमिली ऑफ गिवन कर्व ऑर्थोगोनली perpendicularly or orthogonally is called orthogonal trajectory. This is the definition. Is called what? Orthogonal trajectory. If a curve touches or intersects each member of the family of the curve according to given law, it is simply a trajectory. If the curve which intersects each member of the family of given curve orthogonally, perpendicularly, that will be called orthogonal trajectory. Now, the question the student posed that why we use there the differential equations, concept of differential equations. Now, this is clear, because it is the differential equation which represents that equation. It represents that equation which is satisfied by each member of the family of the given curve. Each member of the family of the given. Very simple. Suppose I will again give you some. The students who are watching this video, it will also help them in future. You see, I am given a curve. It is given. I am given. Find orthogonal trajectory to curve x square plus y square plus 2gx plus c is equal to 0, where it is given, where g is parameter, where g is parameter. It is the curve. Student was asking me, why do we switch on differential equations? What is the reason? The reason is this: if we go the definition, we have to find out that equation which is first satisfied by each member of the family given by this. We have to find out what is that equation which gives the each member of which is satisfied by each member of the family given by this equation. For that, you have to develop differential equation. Develop differential equation. Eliminate parameter g, because he says g is a parameter, c is some constant. Take it here. So you will write 2x plus 2y dy by dx plus 2g is equal to 0. Find the value of 2g. Use 2g here. You have found out that equation. You get why we use the differential equation concept, because differential in orthogonal trajectory, the definition says it is a curve, any curve which intersects each member of the family orthogonally. So when we talk of member, we have developed an equation which represents the each member of the family, in other words. Now after that, In that equation you replace dy by dx by minus, yes, you replace, in this equation you will get dy by dx, you replace it by minus dx by dy. Why? Because you know, when two curves are, actually first you know what is the angle between two curves. It is the angle between their tangents at common point of intersection. So what is the slope of the tangent there? It is dy by dx. When another tangent becomes orthogonal to that, what will be the slope of that? It will be minus dx by dy. Okay, because we know that if two lines are orthogonal perpendicular, then product of their slopes is minus 1. m1 m2 is equal to minus 1. If there is dy by dx something, then the curve which is orthogonal to another, we should have the slope minus dx by dy. That is why we replace there dy by dx is equal to minus dx by dy. Then solve the differential equation and you get that curve which cuts each member of the given curve orthogonally. The concept is actually differential equation concept. It is differential equation, because when you want to find out the given a curve y square equal to, you are given a curve y square equal to 4ax, you want to find out that equation which is satisfied by each member of this, the equation which represents the members of this. You have to find out the differential equation, eliminating here constant. It is also used in finding the trajectories or orthogonal trajectories. So the concept is clear, why we take the help of differential equation in finding out the orthogonal trajectories. I will also devote 1 or 2 lectures on this orthogonal trajectories, their application, because we have orthogonal trajectories for algebraic curves and orthogonal trajectories we find for this what is called this polar curves. I will share 1 or 2 lectures on that surely, inshallah. And this time I wanted to introduce something about, first, it is the first lecture on differential equations I gave you, first lecture on differential equations, and next lecture will be now what is actually definition of differential equation, how we find out it is order, what is the ODE, ordinary differential equation, PDE, partial differential equation, so on and so forth. And you will revise this till then, and stay safe and from all precautions or sources of COVID-19 which are being given that guidelines by the government. Thank you very much. Wish you all the best.